In the early morning of Sunday 11th of December 2005, a large explosion occurred at the Buncefield oil storage depot near Hemel Hempstead, Hertfordshire, followed by a huge fire. Fortunately, there were no fatalities, but 43 people were injured and significant damage occurred to both commercial and residential properties in the vicinity. In January 2006, the Health and Safety Commission appointed 6 individuals representing the Buncefield Major Incident Investigation Board to oversee the formal investigation into the Buncefield accident, which was performed jointly by the Health and Safety Executive and the Environmental Agency. The investigation determined that a flammable cloud was formed by overfilling and spillage of some 300 tons of unleaded petrol from a big storage tank, which was subsequently ignited, resulting in the explosion. The third of 3 progress reports from the Investigation Board issued in May 2006 stated that the magnitude of the overpressures generated in the open areas of the North Gate and Fuji car parks is not consistent with current understanding of vapor cloud explosions. The investigation has so far been unable to establish why the ignition of the vapor cloud and the explosion propagation in the relatively uncongested environment of the adjacent car parks caused significant overpressures that produced the severe damage to property. It was at this stage that Gexcon were approached by Total Petrochemicals to assist in the investigation of the accident. As an initial task, Gexcon personnel performed a survey of the remains of the Buncefield oil storage depot on June 29, 2006. This survey concluded that the congestion present in the tank farm was not sufficient to explain the high overpressures that had occurred. However, examination of the area rapidly led to the theory that the significant congestion formed by trees and undergrowth along 2 roads surrounding the site could be responsible for flame acceleration and high overpressures in the flammable cloud. Gexcon took this theory into the FLAX explosion and dispersion simulator. The oil depot and the surrounding suspect congested tree areas were modeled. Simulations of explosions of a large, shallow butane air cloud were performed, which showed that with trees included in the model, very high overpressures were generated. In some cases, more than 10 bar was seen locally, which is high enough to be consistent with the damage observed. Without trees, very low overpressures, typically of 0.1 bar or less, were seen. These results were presented to the Health and Safety Executive in May 2007. In September 2008, Gexcon carried out further physical explosion tests in undergrowth at a range in Norway, which also produced supporting results. Unobtainable information of gas cloud size, location and composition prevented the simulation of a true representation of the actual explosion that took place. However, the simulations do show that the FLAX code, which has been developed for use in industrial areas and is widely recognized for its ability to produce realistic overpressures there, also produces realistic results when applied to the Buncefield case. The work performed by Gexcon is not proof that the presence of the trees is the sole reason for the high overpressures. However, work presented in 2009 by the Fire and Blast Information Group supports Gexcon's conclusions that trees indeed played a significant role in the development of the explosion at Buncefield.